Go.
Hey guys, so today we're working on a wannabe STI. Right here, where my finger's at, this is the ECT sensor.
Over here on top of the airbox, we have the MAF sensor. On this vehicle, the intake air temperature sensor is actually built into this MAF sensor. Here we have a wiring diagram for the engine coolant temp sensor of this vehicle.
So right now we have back probed into the engine coolant temperature sensor connector. As you can see, we have leads connected back here to our meter. When the engine is cold and the vehicle is off, the resistance is 1.149-ish thousand ohms, so that's 1100 ohms roughly. So once we heat the sensor up, it should change resistance. So while the engine is off and cold with the key in the on position, the temperature sensor here is dropping about 3.4 volts. So as you can see, as the vehicle warms up, the voltage reading slowly drops as the sensor drops less and less voltage because the resistance is actively decreasing.
Alright, so car's slowly starting to warm up. We're sitting at 53 degrees Celsius on coolant temperature, and for IAT sensors, sensor, we're looking at 25 to 27 Celsius.
Alright, and if we go up front here, on our multimeter, we can see that the voltage reading is now 2.03 volts dropping over the sensor because the resistance has decreased.
Alright, so the car's pretty warmed up now. As you can see, the coolant temperature is up to 71 degrees Celsius, and IAT didn't go up too much. It's at 27 and 32 degrees Celsius right now.
Alright, so if we head over here, you can see that the sensor is now only dropping about 1.42 volts. So we will now unplug the sensor to simulate an open condition. So if you just go down here. So once the sensor is unplugged, you can hear the engine operation change. The coolant fans automatically kick on because the car believes it may be overheating. Here on the scan tool, you can see that the coolant temp is at negative 40 degrees
Celsius, and this is because at negative 40 degrees Celsius, both Celsius and Fahrenheit are at the same number.
As you can see, the connector is also dropping 4.76 volts. That's unplugged. It's almost a full 5-volt signal. So as you can see, we'll now short the coolant temperature sensor to see the results on the engine. So if we short that together, the resistance will drop to 0. As you can see, the engine goes into a fail-safe mode, and coolant temperature is registered as 119 degrees Celsius.
Okay, so after messing with the engine coolant temperature sensor, we got the P0117 code, which is current. Engine coolant temperature sensor 1 circuit low, and then due to unplugging and shorting it and messing around with it, it also stored a freeze frame data code right here, P0118, engine coolant temperature sensor 1 circuit high.
Alright, so as you can see here, we have the MAF sensor, intake air temp, and sensor also pulled up. So we're about to unplug the intake air temp sensor and see how it affects the vehicle. We are unplugging the intake air temp and MAF sensor here. As you can see, the engine stuttered very much and almost died. Gas airflow value is shunted down to 1.4, and one of the intake air temperature sensor values is at negative 40. The other intake air temperature value seems to be correct, which implies that this is from a second intake air temperature sensor. So upon further review, it appears that this MAP sensor actually also has an integrated air temperature sensor. So when that one was unplugged, the vehicle was using this one to run. However, when we unplugged this one, the vehicle immediately died. And the other value also went to negative 40.
We will now be working on a Jeep vehicle, specifically on the throttle position sensor. The diagrams here show the wiring for that throttle position sensor as well as the expected value.
Guys, today we're going to be working on this Jeep here. So right here we have the idle air control valve, and then right up here we're going to be testing the throttle position sensor. This back, the very back wire is black, so that's our ground, and then here in a second we'll figure out what these two red wires do.
So right now we are testing on the ground pin. As you can see, the voltage is currently at 0 since we are testing from ground to ground. Now if we go over to the signal pin here, the middle one, you can see we have about 0.62 volts. So that's the sitting voltage with the throttle closed. And if we go to the power pin over here, the last one, you can see we have the full signal voltage, which is 5.2 volts on this vehicle. So now we will be performing a voltage sweep test on this this throttle body. So as you can see, we are testing from the signal pin to ground. And if you look at the meter, the voltage should change as we move the throttle. When it's closed, you can see the voltage is at 0.62. As we open it, you can see the voltage slowly go up until we reach the maximum open position, which sits at 3.97 volts.
Our last vehicle will be a 2017 Hyundai Tucson. We'll be testing the two throttle position sensors for the ETC on this vehicle. Please reference the wiring diagram shown here for the wiring on these sensors.
So when we press the gas pedal, you can see on one of the channels, the voltage slowly moves up as the throttle changes. As you can see, the throttle is now open. So when we let go of the gas pedal, you'll see it goes back to 4.2 and the throttle blade closes. All right, we are now testing the second throttle position sensor. So this one starts off at a low range of 0.8 volts. When we hit the gas pedal, see the throttle opens and the sensor goes up to 4.2 at its open position, and when we let go of the gas pedal, you can see it goes back down to its low position.